Okay, on a problem like this is 12-124. First thing, go ahead and draw yourself a free body diagram. And even though B is not touching, go ahead and show it as a force coming up here. Force coming down up at A. We'll have one at C. Now this is going to be a distributed load here, so you're going to take 30 kilonewtons times 12. That's going to give you 360 coming down. So we'll put that one coming down right here, like that. We'll go ahead and label that as 360 kilonewtons coming down. This will be the force at A, force at B, sorry, force at C, and the force at B. At this point, we can sum our forces in the y direction, and we'll get F of A plus F of B plus F of C minus 360 is equal to 0. We can take a moment around A. We will get 360 times 6. We'll make that negative because it's going down, plus FB times 6. Get B better. Let's change that so it doesn't get confused there. B times 6 plus FC times 12. Okay. Simplify as much as we can here. 360 times 6. This equation right here, we can make it into minus 2160 plus FB times 6 plus FC times 6 is equal to 0, and we could just divide it by 60. I should have done that at the beginning. That gives minus 360 plus FB plus FC is equal to 0. Make sure I put that over here. So these are your two basic equations, but you're back to the same point as you were. Previous problem is you have two equations, but you have three unknowns. Okay, so what you want to do here is to work on finding what the deflection is going to be here. Now, you notice here you already have 0.2 as far as the deflection goes. So what we're going to do is we're going to find out what the deflection is going to be by the single load and by the moment or the distributed load here. That's what we're going to do first. So we'll have to go to the equations to do that. Okay, so now we're going to go to our deflection equations, and we'll go down to number 6, which is the distributed load. And you can use Y max, and it happens to be, but if not, you can use the other equation to the far side. But W max is equal to minus 5 times W times L over 4 over 384 EI. Now W in this case would be our 30 kilonewtons here. We knew multiply by let's think about that. Kilonewton meters. Okay. Well, I'm being breakdown. Okay, sorry. So we put that value in at minus 5 times our 30. Now our length of our beam is going to be 12, so we're going to take that to the 4th power. Okay, and by EI here, and that's going to give me 8100 kilonewton meter cubed over EI. Okay, and again, we'll make that negative here. So let's do that. So that's Y due to the distributed load. Okay, so now we have that value there. Now we go back to the picture, and there's a couple things taking place. As this beam bends down like this, something like that, what's going to happen is this member here is also going to deflect. When it comes down, it's going to hit this thing, hit this. Well, B is going to be pushing back up on this beam, as well as the force is going to be deflecting this beam. So we have to consider that one. So the Y, as a result of FB, is going to be positive. We go back to our diagram, or I'm sorry, our tables, and we look at number 4. We have a load right in the middle, and it is going to be PL cubed over 48 EI. Now let's do the arrows. This is going down, this is going to go back up. So we put P as being the force at B times the length, which here will be 12 cubed over 48 EI. That's going to give me a value of 36 FB over EI. Again, that's going up here. Okay, and that's YFB. Now, we consider this guy has a length, it's going to deflect, so that's going to be a PL over AE type of equation. Basically, that is PL over AE. What's making it deflect is the force of B times its length, which is 1 meter, over its area. Let's see if it gives us area here. Diameter of 40 millimeters. So we'll do pi r squared, or pi d squared divided by 4. So we'll do pi times 0.004. Hang on, I got too many zeros in there. Let me change that real quick. That, and let's just see if the materials are all the same too. Okay, so we're just going to put E into that because we have the value here. Alright, so we'll run the calculator real quick and see what we get with that one. So a 1 divided by, in parentheses, second pi divided by 4 times 0.04. That gives me a value of 795.77 F of B. Again, that's going to be over E here. And we got that value. And the deflection here is going to be going down also. Okay, and the only other deflection that we have is given as, I'm going to erase this, 0.02 is our other deflection. Okay, so now we have everything we need. Alright, so now we're ready to solve this problem. And the O2 deflection, let's make sure that's in millimeters. Alright. So I can do 0.02 times 10 to the minus 3 to get that back into meters, plus the deflection that this is going to cause. Okay, we're going to make that to be a negative deflection, and we're going to make that be negative deflection, and that must be equal to the total here, which will minus 8100 over E I'll make it better. 8100, excuse me. Over EI, and then plus this one here, which is going to be 36 FB. And I need to do FB over EI. Okay, now I'm ready to solve that. I can go ahead and multiply, if I want to, everything by the value of E. And only thing it does is it makes it a little bit simpler. Okay, so now we're ready to plug in the values. We know the value of E, and we know the moment inertia of the value of I. All you have to do is put those values back into there. That's E is equal to 200 gigapascals. The I value is listed as 875 times 10 to the 6 millimeters fourth. So we'll make that times 10 to the minus 6. We'll do the 200. That's going to be in gigapascal, so it means 10 to the 9th. Okay, all you have to do now is put that in here. And this is FB, and solve for FB. Move FB to one side, and when you do that, you'll get a FB as about approximately 219.7x kilonewtons. Okay, and then once you have that, take it, put it back into these equations here, find FA and find FC, and you'll get FA is equal to FC, which is equal to 70.11 kilonewtons. Okay, good problem here. The thing to note is, just remember this is your total deflection that's got to take place. Again, that should have been equal sign here too. I'm sorry about that. This is total deflection that must take place, and this is what's causing the deflection here. Set the two equal to each other, and then solve for FB. And no problem. You can get this problem without too much trouble.